Hello class, today we are going to discuss relations and functions. So let's take a step back to algebra and consider this linear equation y equals 2x plus 5. One way to display solutions is through a mapping diagram. Mapping diagram is very similar to an XY chart. So when we have a mapping diagram, we have an x values and we have y values. Our x values are considered our input values. If I input the number 1 into our equation for my value of x, my output is going to be 7 because 2 times 1 plus 5 equals 7. Again, if I plug in 3, my output will be 11. And if I plug in a negative 13, my output will be negative 21. So what we're creating here is basically a set of ordered pairs. Any set of ordered pairs is called a relation. So creating the input-output values together, making them ordered pairs, that is considered a relation. So here's an example. Any set of ordered points. So here is a set of points, 1, 0, negative 2, 3, 4, negative 1, 9, 3. They are considered a relation. We can also look at relations in a graph form or in a picture. I took the previous points and plotted them on a coordinate plane. There's no rhyme or reason to how these points look on the graph, but if they were creating a straight line, what does that tell us? Well, a line is a set of many points. So is a line a relation? Yes, a line is a relation. Let's take a look at two pictures of lines, or two graphs rather. We have a positive slope, we have a negative slope. Either way, they are created by a set of ordered pairs forming that line. So any line has many points, therefore any line with the equation y equals mx plus b is considered a relation. We also have what's called domain and range values with relations. And domain values are just basically a listing of all of your x values or all of your input values, whereas your range is a listing of all of your y values or your output values. So take a look at the example that we were just referring to, and let's think about what the domain and range would be for the set of points below. Try it on your own. Think. X values is just, domain is just the listing of all your x values, and range is a listing of all your y values. So in this example, domain would be the numbers 1, negative 2, 4, and 9. And range would be the numbers 0, 3, and negative 1. In the range values, notice that we only have 3 numbers there, but really there are 4 points. The number 3 does repeat, not necessary for you to write it twice. Let's now consider the equation x equals y squared. If we try to do a mapping diagram of x equals y squared, if I plug in the value of 9, the value of 9 is going to give me an output of 3. But is that the only value? If I plug in 9, 9 equals y squared. The inverse of squaring y is taking the square root. Is the square root of 9 only going to be able to be 3? Think about that. Let's plug in a 4. If I say 4 equals y squared, can y equal negative 2? The answer is yes. Is there more solutions when x is 9? Yes. Is there another solution when x is 4? Yes. If we plug in 9, technically, we are getting 3 or negative 3 because the square root of a number can be the positive or the negative of that root. When we consider a function is a relation, but it is a special relation. It's a relation where the two variables each have a value, and the first variable is paired exactly and only with one value of the second variable. So for instance, my input can only have only one output. If we look at the mapping from our previous problem, my 9 had 2 different outputs. So each input can only have one output. So although this equation, x equals y squared, can be considered a relation because it is created by a set of points, More specifically, it is not going to be a function. This is not going to be a function. X equals 9 has two different output values. So if we look at these two examples here, our previous example that we've been looking at, 1, 0, negative 2, 3, 4, negative 1, and 9, 3. This one would be considered a function because none of your y values are repeating. 1, negative 2, 4, 9. They're all different all different x values. For the next example, this would not be a function because if you look at your x values, 1, negative 2, 1, and 9, those ones are repeating. Because those ones repeat, this is not a function. It's a relation, but it is not a function. Let's now look at a linear equation. Is y equals 2x plus 1 a function? Well, let's plug in some x values and create some ordered pairs. If I create these ordered pairs, you can plug in any values you want. Here's a few that I've plugged in. If I plug in the number 1, is there ever a chance for me to have another or a different y value than 3? Could we ever reuse an x value? No, we could not. Since no x value is repeated, y equals 2x plus 1 is in fact a function. So, any equation y equals mx plus b is a relation as well as a function. It must be in y equals mx plus b form though. Let's also consider some graphs. Does the graph represent a function? Does this circle represent a function? Think about what a function is. A function is when no x values are repeating. Let's take a look at, let me give you a hint here. Let's take a look at coordinates. Those two dots, one on the top of your graph, one at the bottom of your graph. What are the coordinates of those points? The coordinates of those points should be 0, 2, and 0, negative 2. What do you notice here? You should notice that your x value is giving you two different y values. Therefore, a circle is not a function. Consider the graphs on this page. Are these three graphs, functions? An easy way to determine whether or not they are functions is to use what we call a vertical line test. If you have any vertical line that intersects a graph at more than one point, then the graph is not a function. So any vertical line intersects a graph at more than one point, the graph is not a function. So let's put that to use. If I have this graph right here, if I draw a vertical line, is it hitting the graph twice? Yes. So since it is failing my vertical line test, this figure or graph would not be a function. How about this one? If I draw a vertical line, is it going to hit the picture twice? No, it is not. Therefore, it is passing the vertical line test, and it is a function. And last, is this graph a function? If I draw a vertical line, it happens to hit my graph twice, creating a failure in my vertical line test. Therefore, it is not a function. Function notation is used in many different ways. If we take a look at a word problem, the height of an object, x seconds after launch, can be expressed by this function. We read this function as f of x, that's how we say it, f of x equals negative x squared plus 5x plus 2. Very similar to our input-output. X is the independent variable. X is our input value. I can plug in a value for x, and I will be given an output value in the form of f of x. F of x would be considered the dependent variable. We will get further into evaluating functions, but this is just an example of questions or problems that you will be able to complete by the end of this unit. If you take a look at this, to kind of go in a little bit more detail of this problem, what is the height of an object 3 seconds after it is launched? Well, I said that x was representing your number of seconds after launch. So if x is 3, if I evaluate the f of x function when x equals 3, That basically just means that I'm plugging in the values of 3 into that linear function. And when I evaluate that function, I have an output value of 3. So what this tells me, I have an output value of 8. So what this tells me is that after 3 seconds, your object will be 8 feet high. Brainstorm on your own. What is the height of an object 4.5 seconds after launch? See if you can come up with an answer. Thank you very much for listening. Please feel free to review this video as many times as needed to ensure that you have copied down all the necessary notes and understand all of the material for class tomorrow.